So now it should be better. Sorry about that. So as I mentioned, I have, so this is the 2 grants that I was talking about with the University of South Florida and University of South Carolina, with PIs Dr. Ghani and Dr. Jorge. And so most of my work is related to data science for cybersecurity. We do a lot of internet measurement for security, anything from a network level perspective to address evolving problems. So in the past, I did a lot of work on probing analytics, probing botnets, how we can leverage intrinsic network features to do botnet analysis. Recently, we have been working on IoT security, how we can detect such exploitations in the wild, how we can do some operational also active security measures to proactively remediate such exploitations. So I'm in the realm of cyber forensics, if I may say. Also, I'm part of the cyber center here at UTSA, and the UTSA is actually, the cyber center at UTSA actually includes around 25 faculty members working on different aspects of cybersecurity or the interrelation of cyber with these themes, basically, right? So a lot of guys do a lot of malware forensics, cyber physical system security, digital forensics. So this is your traditional digital forensics, and any application of really data science to cybersecurity as well. And there's a bit of folks also that do a lot of behavioral analytics. So to model the behavior of, especially for insider threats. So if you're interested, we have all our work and publications on ResearchGate. We have a Cyber Center ResearchGate profile. So I invite you to go through that. Our work is normally we try to tie in these aspects: the industry and the government, the academia. This helps for many things, basically. One thing is that it will we can actually come up with impactful research problems that the industry and government are working on. We can also pull empirical data from the industry, for example, to do some impactful work related to critical infrastructure security, malware, as Dr. Haywood mentioned, right? Also, we work with academia, for research collaborations, proposal, and then obviously government for proposals, and then contracts to do some work. And the idea is to have this feedback loop to really benefit all these parties. So in the past, I worked with Georgia Tech, we worked with DHS, Cisco. So some of these collaborators, and I think the theme of this workshop is that by just looking at the participants and the security panel later on, you will see that this theme is actually a very impactful, very fruitful kind of workflow for addressing various problems in cybersecurity. Okay, so the last slide I have on the center, I don't want to bore you with this information, but the idea is that we also do different aspects of it. Obviously, training is a big part of it, and this is part of this workshop and the impact, on training on minorities. We also focus on specific, I call them opportunistic studies. So if there's an event in the wild, for example, happening, like when the Mirai botnet happened about the IoT, we can delve into this. Back in the days in 2014, when we had some scanning coming from source port 0, we did also opportunistic studies. And the center is focused on these, apart from your typical R&D projects from different funding agencies. Okay, so next I will elaborate a bit on Zeek. First of all, let's address the elephant in the room. Why why Zeek, bro? Why we always use this terminology, and you will see it in the labs as well. So initially, obviously, we all know that bro was created back in the days by Vern Paxson, right? He's obviously very known in the field, world-renowned, if I say. Probably some of you, watching this have worked with him or worked with the ISC from Berkeley. So initially was the BRO, Intrusion Detection Systems, was developed by Vern Paxson. And then obviously through the days, things have changed. Now there's like a commercial, version of BRO. They call it the Core Lite, basically. I don't want to be too, I'm not advertising here, but they actually, moving towards commercialization, they thought that, Bro is not an ideal naming anymore. So that's why they went with the Zeek, which actually has something to do with the Greek mythology, but, or some event in the movie, I don't remember. Anyways, as you know, in the labs, sometimes you will see interchangeable between Zeek and Bro, but moving forward, it's all gonna be Zeek basically. Okay. So for the, obviously many of you already know this information, but for the audience that don't know, network intrusion detection systems are extremely widely known in any environment, operational, industry, academia, government. A question that arises normally is, okay, especially for for people that are not very familiar, is what's the difference between an IDS and the firewall, right? And you can think of it as the firewall is your gate, right, doing some binary classification of letting in through the data or not, and your IDSs are mostly kind of your internal sensors, right? They do signature detection, anomaly detection, right? And as we know in security, the addressing the many problems is a layered approach, right? Is a layered approach in the sense there's no one solution, right? So every aspect, every solution provides its own stuff, so its own benefits. So IDSs, right? IDSs can work also in intrusion prevention, so they actually can drop the connection, for example. But mostly they work on anomalies or signatures, right? And now the definition of anomaly differs between different fields. So, for example, in machine learning and data mining, an anomaly is any deviation, right? Any deviation to non-normal behavior. In cybersecurity, I think anomaly is mostly also, yes, it is a deviation, but it's mostly also malicious deviation, right? And also, again, this brings to the point, the idea of false positives and false negatives, how we can distinguish between, a benign deviation and the malicious deviation. And in security, when we talk about security, really we're interested in these malicious deviations, right? And yes, in the older days, we were IDSs did a lot of this, but think about it more on a critical infrastructure aspect, where we have some say a power grid or a water facility, and you inject, or an attacker injects, for example, some anomalous sensor measurements, right? So if the water facility, for example, is injecting certain chlorine, for example, just to do some cleaning for the water, obviously an attacker would like to increase this set point, so he will push a lot or maybe less chlorine to actually cause issues with the water quality, right? So here anomaly is basically this deviation, and there's a lot of work has been done on using anomalies to detect stuff like this. So yes, in terms of high-speed networks, maybe this is a kind of old news, but it's really applicable in critical infrastructure, and there is a lot of IDSs that are tailored with certain signatures, with certain of learning algorithms as well to detect these anomalies in critical sector, where typical IDSs do not operate well because of lack of signatures or understanding of the context itself. So as I mentioned, this is kind of the initial concept of how Zeek operates, right? So the core of Zeek is really this event engine and the policy interpreter, and through the labs, as I'll discuss in a few slides, and as you see, when you are actually doing these labs, is that a lot of work can be done on this. Actually, this is why most of the labs are actually focused on this event engine and the policy interpreter, in the sense that it allows you the flexibility to handle, different packet features. It will allow you to create different detectors, right, to react to certain the packet streams, basically, right? And we have also dedicated labs on the output, on how we can process the output in a neater way, if I may say, how we can leverage even this output to invoke machine learning algorithm, right? So as Dr. Haywood mentioned, we need this, kind of proactive approach or continuous learning, right? So we can feed this output to certain learning algorithms that are being generated actually from Zeek to do some advanced analytics. Yes, this is the Zeek core, but also the labs were focused, when we create the labs, is to actually focus on some, from initial, initial understanding of what is Zeek, to actually developing the different detectors, to actually using the outputs for learning and advanced analytics. Okay, and actually the first lab that I'm going to go through today will introduce a bit, very limited, I mean, just some capabilities about this Zeek score, if you want to say, and so the initial lab, the introduction lab, actually goes through a kind of narrative about design of this of Zeek basically. So a big aspect of any IDS was the the employment of signatures, obviously. And the idea here is that I receive a flow of information traffic, of network traffic, and again, flow. The definition of flow could be a bit hazy. Is it the 5-tuple, with the source, destination, source port, source destination port, and typically the transport layer protocol? But typically it's this 5-tuple information. So I receive this flow information on the network, and the IDS will basically look at this information and say, does this flow of network information matches any of my signatures? And if yes, what shall I do with it? Basically, this is in a nutshell what happens, right? So if you're familiar with Snort, so this is also very famous IDS in network intrusion detection systems, and I put this information here just to kind of do a small comparison between what's the Snort signature that is also open source and has also a commercial entity and has been adopted in many commercial appliances as well, compared to Bro. So this one, for example, just is a rule that will say, if I observe traffic coming from any source targeting any destination as well, targeting from port 80 or targeting port 80 to this destination, then do something about it. Okay. So you see that transport layer protocol, you see the direction of the traffic, any basically, and what should I do, right? I have an identifier here which basically will be used as an output, and the configuration of this is inside this, okay, in this configuration file. And depending on this configuration file, the IDS will react. So this is the same kind of terminology or methodology that Bro will use, that I will show you in a few seconds. So one thing that I would like to mention from this slide is that the IDS by itself here, for example, is just working on flow analysis, right? Both Snort and Bro have the capability to actually do some deep packet inspection, DPI. So I, for example, in the older days, I did some work on Snort, and we used to write these what we call PCRE, Perl compatible regular expressions, right? And they were, this was a huge learning curve just to how to write them and embed them in Snort signatures to actually do some DPI. I know there are some automated tools also that will convert feature package into a PCRE compatible DPI signatures. But some it should be noted that although this is flow analysis, you can actually do DPI on this information as well. Okay, so in comparison to Bro, in comparison to Snort, Zeek also has a similar signature that does the same thing. It's just the format is much different. So it's still take from an HTTP configuration. It still defines a transport layer traffic and the source and destination networks, and obviously what you have to do, right? So in this case, you have the payload information. If it's set up, then it will use this information. And actually, we have two dedicated labs, one in the current iteration of the lab. So I'm trying to give just context because I think this is what you see value in it eventually in the labs. So in the current labs, we have 10 labs that I will talk about them in a few. One of them is about the signatures, but we are working on, actually we finished developing 3 other labs. One of those labs will be dedicated on how to actually mold these signatures, create these signatures, and use them for offline and real-time, IDS usage, basically with Zeek. Okay, so don't worry too much about, if you're, an entry level or so there are labs that will help you actually dig deep into this as well. Okay, so another aspect that I would like to shed light on is the log files, right? So every time you process network traffic from Zeek, whether it's log traffic or real-time traffic, there's a bunch of log files that will be generated. Okay, and I will, one of the labs that I'm gonna go through, I'm gonna show you actually the notice log and the connection log. And the beauty of these logs is that, apart obviously from generating information that I can use for like forensics, for example, I can actually use these log files as an input to other programs, right, to other utilities that Zeek provides and other third-party, I would say, Linux-based services or daemons for ingestion, basically, right? So I can use this as an input to Zeek Cut, which is the utility in Zeek that we have actually a lab on to do some further processing. I can give it to maybe a big data analytics platform or to do some near real time also visualization of the data. So yes, this information is crucial, but normally these are also ingested, right, to other third-party services, daemons, to actually do further analysis. And one thing that you should realize in Zeek, at least in the open source version, right, because here we're not talking about the commercial version that forked later on. We talk about the open source version, and the open source version actually is kind of very raw in the sense that it's a compilation. You compile it, and then there's not much by default supported services for like performance logging, for example, nice visualization. So the logs are just dumped on the disk. The performance really there's nothing to do there. So you have to work with the raw set of things, and this is why they did actually create a commercial version, and this is why there's a lot of third-party services that will work on this, right? But hopefully through the labs you will see a foundation of these Zeek, foundation of using these output logs to actually develop more advanced stuff and build on stuff that you can actually use in your operational settings or tweak it, or also for purposes of training. Okay, so this is the power of this. Again, these are typical text files that you can ingest, and depending what you are doing. So for example, again, the notice log is similar to, I would say, to the if there's some sort of a malicious activity, then the notice log will arise. If I'm doing a simple ICMP ping commands or ICMP scanning, then there's some connection log. So that you can see basically. So what about the core of it? So as I mentioned, the core of Zeek is these scripts, right, and filters that you can use and you can develop. And we have 2-3 labs on that, on how to basically bring the application of Zeek to a next level in terms of especially on the anomalous detectors. How can I build a filter, for example, that will maybe do some what we call a non-permanent filter, right? So these filters that are applied on log traffic, for example, or maybe on real-time traffic for a certain period of time that does something, right? These scripts also that actually will create new detection engines, right? They can be handling certain application dependent. For example, I'm talking FTP, for example, or SSH. I can use it just for handling UDP traffic, right? And doing some analytics on that. And I can show you one use case also related to that in a few slides. Okay, so basically, you will mostly be working with these scripts and to allow the Zeek's engine to react to certain malicious activities, and as well as output files that could be used for other advanced analytics. So, for example, a very simple, a script here. If you can see here, for example, the custom-based detector. So this is, if you look at it, you can directly know that it's talking about scanning. And so what is this basically is a behavioral kind of analytics that will monitor flows coming from certain sources, and within a 5-minute period. So think about as a moving window, right? And within that 5-minute window, it will track flows coming from a certain source. And if that source actually generated more than 20 in this case, because we have this threshold, then what I'll do is what the Zeek will do actually is will detect or will generate an alert, right, in this notice log that a horizontal scanner has been detected. Right, so a horizontal scanner detected is actually is when there's a source that is scanning different destinations. In this case, 20, typically on the same port. Right, so obviously this script does not dictate the port, but it has to be mentioned that there should be a definition that the same port has been hit to actually generate a horizontal scanning alert. Right, because without the port number here, we can have, for example, a vertical scan, or maybe a hybrid of, a strobe, right? What we sometimes in the literature they call it a strobe scan, which is basically scanning all the IPs on different IPs on different ports. Okay, so on the upper left corner here is we have the typical transport layer protocol related to UDP. And this is basically nothing, it's nothing malicious. It's basically saying that every time I see a UDP request, I can notify my IDS or my admin basically that there's some UDP traffic coming on. And this UDP issue here actually triggers a very very neat research problem about observing UDP replies. As you know, UDP is a connectionless protocol, right? So a big problem, for example, is how we can detect UDP replies. Why? Because this is very important in a problem in security that we call denial of service detection through backscatter traffic, right? So backscatter traffic is basically the replies of a denial of service attack to a spoofed IP address, right? So an attacker or a botnet have spoofed the IP addresses, launched a UDP attack, and the replies, basically this is what we call replies or backscatter, will come from this victim, basically. The problem is that in TCP, it's very easy to distinguish between TCP SYNs and their backscatter, their replies. So as we observe these replies or these backscatter, we can directly identify the victims of the TCP attacks, right? So in this case, UDP is a bit challenging, right? Because we are not sure how we can identify UDP backscatter. And there are, few words on that, but I think, for you guys that are watching and, you are actively in research on this side, you might agree, or maybe not agree, but at least you can relate more on this, that so there's a lot of need to do some more UDP analysis on this side. So I have a few slides on how we have been doing some work on the on basically leveraging some of these capabilities basically here in terms of custom-based Zeek scanners, Zeek detector scanners for a real problem, right? So Dr. Haywood mentioned, that there's obviously, the IoT problem is a big problem, and we have been working here in the lab with collaboration with USF and USC on this IoT security problem. And I always like to put this slide because the baby on the right is a bit scary, but it's a real problem. And this spiked actually initially when the Mirai botnet got attacked, launched at the beginning. And then a lot of reports started generating about these IoT exploits. And the problem here that we had is, or the research problem that we had is how we can actually detect such exploitations. Not all of them, but at least have some vantage point that will actually look into this IoT problem and notify the ISPs, notify the whoever is actually operating these IoTs, their IoT devices have been exploited. Okay, so obviously it has some privacy aspects like what you see here, but there's a big also security problem, right? With many vendors just pushing their devices for functionality, but not many people are actually, not many vendors are actually taking care of, their vulnerabilities, their IoT vulnerabilities. So we've been working for the last 2 years on leveraging, network traffic data and leveraging, some custom-based scanning detectors to be able to observe some vantage point coming from these, or network traffic coming from these compromised IoT devices. So in a nutshell, the rationale here is that the IoT devices, when they are compromised, apart from being leveraged in the botnet, obviously, they are invoked to actually also scan other assets, other internet assets, and these assets could be other IoT devices to do the exploitation, or other assets, typical host machines and stuff like that. So a typical approach to detect or to see scans, internet scale scans, has been always to look at what we call a darknet traffic. And don't confuse darknet by the dark web. For the people, no, darknet is just a subspace of the internet space. Okay, so if this is the internet space, this is a subset that is also routable. So it has the same feature as the internet address space, but there are certain sensors here that are actually operating non-legitimate machines, right? So these are sensors that are passively collect network traffic, and the rationale is that any legitimate machine on the internet will not send traffic to those these IPs, right? Dark IPs, because they are not operating any legitimate servers, right? And from an attacker or from a scanner perspective on the internet here, this darknet space is indistinguishable from the internet address space, right? So as yes, you see here that they are kind of in one block, but they actually distribute all over internet, these darknet IP spaces, right? So one typical way that has been used forever, and yesterday a few people from ESNet mentioned Qaeda. So Qaeda does a lot of this, and actually we leverage a lot of their darknet traffic. So they operate one of the biggest darknets in the world. It's /8, if I'm not mistaken. So that's around 16 million dark IP addresses that are deployed. So one way to do it is just to observe scans from these IoT devices, and then do some more advanced skills to actually distinguish between scanners that are just launching typical scans and IoT devices, right? So the problem is that really we need to go dig down into these IoT devices than legitimate machines, and we have done a lot of work with USF and USC on this, and with the folks in Montreal at Concordia University as well, to actually yes, detect scans, but also distinguish IoT device from non-IoT, and then do more learning on the banners that we collect and other type of information that we collect by actively doing some scan on their IoT devices, to dig deep into the which sector is actually deploying this. So we leverage also some PSDNS traffic to dig into the the sector, like government versus financial sector versus typical consumer ISP sector, compared to maybe the health sector, and also to be able to try to label this IoT device in terms of vendor, right? So there's a lot of exploitation on Microtech, Dahua devices, other stuff. So if you're interested in this work and how we leverage these custom-based scanners that actually does operate similar to the Zeek scanners, please feel free to look at our ResearchGate as well, recent papers about this, and we can do, a long internet measurement studies on this. And as also Dr. Haywood mentioned about this, pandemic that we're passing through, unfortunately. So we were also interested in the dynamics of these scans before and prior and during COVID. And if you see here, we actually focused on hosts that are exploited, that are compromised in the medical field. And just by looking at few days, you can see that the exploitations within the medical field in the US and around the globe has been significantly increased during COVID. So we are looking into this to see why this is occurring, what are the vendors that are being hit, and which exactly IoT devices in these sectors are being compromised. But the numbers in general are very alarming. We see on average around 800,000 exploitations, persistent exploitations. Some are remediated, some are changed because of the HCP churn. But these numbers are exploited. But this is one use case of how we as a research entity is using actually Zeek scanners to actually do some analytics on this. Okay, so in the remaining part of my this session, I'm gonna just describe the labs and take you through two hands-on labs that I chose for the sake of this. And again, if you have any questions on what I discussed or what I'm gonna be discussing, please put them in the Q&A, and one of the assistants will help, or panelists, or I can get back to you on this. Okay. So for the sake of the labs, and this is why mostly are here, because you are interested in the hands-on labs. And again, NDG helped us a lot on this. And when I first started looking at this NDG that Dr. Jorge mentioned to me, I really wish that during my educational years, I was able to access this, because I remember we did a lot of, at back days, we did a lot of Cisco iOS handling, but really the environments were really bad. Even when we handled VMs, the topologies were kind of cumbersome. So now we're lucky that we have this platform that we can actually develop however labs, whatever labs that you want, with a really nice topology, with a really nice optimized access. So this is really an asset, and I think the whole team really wish that you can leverage it, and hopefully it will be useful for you, whatever you guys do, basically. So for the sake of this iteration, we have 10 labs. Again, as I mentioned, there has been some development in the back end on these labs to extend them a bit, and we will continue to work through the summer on this. And one of the updates that we have is that I'm going to discuss is that we are moving also this from a typical VM setup to a mini-NAP setup, similar to what yesterday was described. So this emulator basically to help optimize basically the deployment of these VMs. But let me go back to focusing on these labs. So we have 10 labs. Okay, today after this session, I'm going to focus on lab 1 and lab 10. Okay, so as you see, let me tell you a bit about the structure of these labs. So I would say the first the first three labs will give you very basic information about the Zeek, its log files, and how you actually can process the outputs basically. Okay, so the first lab that I'm gonna take you is basic. I'm gonna describe it in few, and then we basically in these labs we see the raw outputs, and then a bouquet of kind of utilities that come with Zeek that you can actually use them to easily identify certain fields of interest from the output files. Okay, from the log files. And this is very important because you really need to, if you want to, if you are preparing a presentation or you are actually inputting this information to a third-party daemon, then you need to actually go through these to facilitate the input. Okay. So labs 4 and 5 will dig into two kind of security events, which is the scanning traffic and denial of service. Right. So in these labs, actually, we will learn how to launch scanning traffic, the types of different scanning traffic, some tools of scanning traffic, how actually Zeek can process Zeek traffic, what are the detectors of Zeek that will be applied on this traffic, and then what is the type of output that we can process. A similar thing to denial of service with its tools and detectors, specific detectors. Okay. In lab 6, we actually gonna dig deep into how we can design new scripts for this core engine that we will be able to tune some of the detectors. Okay. Actually lab 6 and 7 has been customized a bit in the new iteration that you don't have access to it not now, but you will have access to actually allow Zeek to do some live live real-time capturing of the data, and how these scripts are actually changed somehow to actually reflect these updates. Okay, this behavior of Zeek when it's running in log traffic compared to real-time traffic. Okay, so 6 and 7 will delve into this newly developed anomaly detectors, basically. Okay, and how we can expand the capability of Zeek to allow this. And 8 and 9, actually, we introduced them here to give you some aspects of how we can leverage the output of Zeek to do some learning techniques on them, right? So how we can prepare the output files to be fed as an input to machine learning algorithms, classifiers. And then 9, you will have some tools, right? It could be command line tools or GUI tools that will give you access basically to a bunch of learning algorithms that will allow you to do such capabilities, basically. And lab 10, given that Zeek doesn't come with any generic or ready, if you want to ship performance, what are some of the tools as well that you can use? Okay, what are the modules that you can activate to actually generate some profiling metrics related to Zeek, whether these are Linux-based or stuff modules that are provided by Zeek. Again, without relying on any third-party services, because there's plenty of them that eventually you would like to use. Okay, so in all these labs, you have the same topology basically. You have 2 Zeeks, Zeek 1, Zeek 2. You have 3 networks of /24, and all these accounts and are available to you. And while I'm doing the labs, I'm gonna go through this lab setting basically to get you familiar with. Again, for the people that just joined, these labs will be given to you for the next 3 months. So you are free to dig into it, go to NDG's the platform, and then do the labs there. And I'm sure that the folks at USC will also facilitate other means to access these labs. So for lab 4, I just wanted to give you 2 aspects, but again, this topology is for all the labs. So for this lab number 4, I just chose it just to show you some of the stuff that you can do basically. So for lab 4, you have Nmap, which is a typical scanning tool similar to Zmap, similar to the other scanning tools. You have some capabilities to actually you will learn how to capture this network traffic, and you will have to learn different Zeek cut, which is a Zeek native command to actually process the outputs here. This is from the connection log to see, for example, the targets of these are destination port numbers. Okay, so this is if you want some of the stuff that you will be able to learn. So while you are doing lab number 4, and same for lab number 9. Sorry. So you will learn basically in lab number 8, you will learn how to modify the output of Zeek to actually prepare the data to actually go through lab 9, which is application of these outputs, right, to detect, for example, similar anomalies using some ML classification. So you'll use the GUI tool, but you can also use you'll be able to use the the command line tool of Weka, for example, or any type of classification to do this type of work. Okay. So if anyone has a question about just the presentation, please let us know. If not, I'm gonna go to actually go through some of the labs. Maybe I can stop for 2 minutes. Just if you have any questions, feel free to ask me some questions here, or ask the anyone that would like to have anything that you would like to say. Any questions, comments? I have no questions here. Anyone on the chats, maybe? Okay, there's no. Okay, so nothing so far. Okay, so I'll go through. I still have a bit of time to go through the labs, so I'll do that. So for the audience that were not here yesterday, we are using, basically we developed the labs. So these Zeek labs and the BGP labs of yesterday and the network labs with Persona are all on the this platform, basically, that you have access to it through your registration, and emails have been sent out to you. So you have accounts, password. If not, please reach out to the folks at USC and they will help you with that. Right? So everyone will have access to this platform. Okay. So this platform basically will allow you access to the set of labs. Okay. So I'll just show you some of the stuff. So if you go to the training workshop, okay, so I just selected, set a lab for me, reserve. If you see here, we have the cyber training workshop. Okay, this is our session, but you will see something similar. You can click, and these are the series that were provided through you in this workshop, basically, right? So you have the BGP, the Zeek, the Persona. So this is covered, yesterday. I will go through the Zeek. Okay, and you will be able to see all the 10 labs that are available for you to actually access these labs. So you have lab 1, lab 10. Again, the manuals. So the manuals are on the website of the workshop, but also you can access them through the labs, right? So if you're not familiar with the environment, don't worry about the labs. The labs manual, they're within the labs and as well as available to you through the workshop's website. So I'm gonna go through the first lab. Typically, when you click a lab, it will ask you for some period of time. So if you click and you somewhere next to the stuff, so this will give you, the timing. Yeah, I don't need more than this. So I'll just reserve. And then this is the lab that I selected. Obviously, there's other, people working on this. So I will just click enter the labs to be able to access the lab. So again, the current topology is running with virtual machines. These are Ubuntu machines that have been kind of, truncated to facilitate the deployment, right? But we have plans to actually deploy this in Mininet. So, hopefully by the end of the summer, we will have these ready for you with the additional 3 labs that we have been working on. Okay, again, I just want to give credit to my student, Antonio Mangino. He was a master's student working with working here at UTSA with us to give us to develop most of these labs with the help of the guys, especially Jose, Eli, from USC side. Okay, so again, if you this is the first time you log into this page, you'll have the topology, and you can actually have these tabs, and these tabs will actually take you through different compartments. And this is the very cool part of this. This is actually what I liked when I logged into the first time to NetLab, to this platform provided by NDG, because it's really interactive, right? You can see the networks. You can, if you click on one, you will open the command line. I will show you, but I just want to show you as well before so this is the content. When you click on content, you have the labs manual, and these you can download them, obviously save them on disk, or you can refer to them through the throughout your lab session. And you can see here the time remaining. You can extend this if you feel that you are actually going behind. Okay. So let me, initially what I'll do is I'll just tell you a bit about the lab, and then I will go a bit to the actual execution. So since it is the first lab, we actually created, sorry, my mouse is, here we go. So we actually created some introduction, similar if you want to the presentation that I went through in terms of the Zeek score. Okay, so this will actually give you some idea about how the Zeek core engine works. So this is kind of to facilitate the entire set of labs, right? You can't, for example, work with advanced signatures if you don't understand the basic of the signature. You can't understand why you are writing some scripts if you don't know the basic idea of what are these scripts, what are these filters, what are these permanent versus non-permanent filters. So the initial set of labs here or instructions will give you some introductory that will take you through the rest of the labs in an easier way. And the remaining objectives of this lab is basically threefold. The first is to show you just a basic command related to the Zeek control, which is a fancy way, a neat way to actually manage the Zeek instance on your Linux box. And then the remaining part of the labs is mostly related to traffic analysis capabilities. Okay, so this will basically allow you to process an offline packet capture that has a brute force attack. And the remaining part here will allow you to actually capture a simple ping command and process that command in Zeek to monitor the connection log, just to see that it's some of the output log files. So it's a very basic lab. I chose it because just to show you that the environment obviously, and some of the modus operandi is there. Okay, so I will proceed with the lab. Again, if you're you are following me, you can obviously do the same. If you find it hard to follow me, I'll try to be as basic as possible. I mean, the lab is very basic as well. But again, remember that you have access to these labs, so don't worry too much now. So you will have all the capabilities to do it. But if you have any questions as well, feel free to raise your hand, and I think one of the panelists can answer your questions, or if I see it, I'll answer as well. Okay. So at any time, you can switch between this. You have this topology here, and we'll mostly work today or in this lab with Zeek 2, okay, that is on 2.2/24. Okay, so the beauty of this is that this is an entire Ubuntu machine, and you can run whatever commands. It's a Linux box basically. So this is the beauty of it. Okay. So the initial thing that I want to show you is Zeek control, and Zeek control allows you basically to manage the Zeek instance. Why do we need it? Because typically when you don't really need it, but typically when you install Bro or Zeek, you have to edit its configuration. You have to maybe restart it if you update something. And other stuff. So a neater way to do this instead of its raw way is to actually have Zeek control, go into Zeek control. Okay. Before actually going to Zeek control, I just want to show you that part of this lab here is that we have a certain setup that is, the topology is set up, but also you have some variable names here. Okay, that are links to actually these absolute paths. So we created these to facilitate your life in few things basically. Okay, so if I go to so if I need to see the status of my Zeek installation, okay, so if I do the go to Zeek directory, which is the Zeek install, okay, it chooses it goes to the Zeek installation, and I have the bin, the binary directory here. You can see that this is where Zeek control and and other utilities like Zeek cut, for example, that you will use eventually in the proceeding labs. Okay, so you can see here Zeek control, which is one of the things that I would like to see. And one way to do it, I can do sudo. Sorry about that. / Zeek control. Okay, so the password is also password, and it's actually in the content here. So obviously, the first thing I would like to do is just verify the status of my instance, right? So I'll type status, but the beauty of this environment or any Linux environment is then if you don't know anything, you can do the man page or the manual page of it, or in this case, you can do the help command. Okay, so there's nothing really to memorize here. Obviously, you have the content, you have the lab to follow it. But if you're, if you want to explore what you can have in terms of capabilities and stuff, you can just type help, and you can see all the stuff that will allow you to do it, right? So you can print the Zeek configuration, right? You can update certain stuff. Obviously, you can restart it. You can check the status and stuff like this, right? So Zeek control allows you to do in an easy way, right? So if I click on, if I type status, you will have, you'll see the status, right? And there's no PID here, which is the process ID, which means basically that you are, you're not running it. Okay, so I can do run, not run, what was the start, sorry, start, okay. And I can do status again, and I can see that the PID, now you have the PID, which is the process ID, and the status is running, basically. Okay, so I can exit this by typing exit, and I will just to clear my screen. So now, since Zeek is active, I'm okay because I can proceed with the lab. Another directory that I would like to show you that is, that you're going to use eventually in these labs is the Zeek Labs, which is at Zeek Labs. Okay, and this will change to the workspace. And if I do ls here, I'll see a bunch of things. One of the things is the sample captures. So these are basically captures that we have pre-configured, and depending on the lab, these may or may not change. Okay, so if I go into these sample captures, okay, you see different sets, right? And one set that one pcap files that you see here is a brute force pcap. Okay, and actually in the second step, what I'm going to do in this lab is to enable Zeek to process this brute force, which is actually an FTP brute force attack towards an FTP service, and I'm gonna use Zeek to actually with a custom-based detector to actually detect this brute force. Okay, so to allow me to do that, let me show you first of all some of the content of this brute force that we actually we collected before. So you may or may not know that one way to do it is TCP dump, which is a filter that will read pcap files, which are packet capture files. So TCP dump, I can do -R to read the brute force. Okay. So if I remove, again, if you're not familiar with TCP dump and you would like to know, just type man then and TCP dump, which is the opens the manual of TCP dump, right? So again, if you have no idea what is it, you see all the switches. You can have elaborative description of what it is, and again, TCP dump and other utilities like this are plenty. There's plenty of resources online. Okay, so again, I'll do TCP dump, and then I'll do reading of the brute force. So if I leave it like that, the TCP dump by default utility will try to do name resolution. and it will try basically to resolve the IP addresses within that brute force through DNS. And I don't want this to happen here because it's take forever, because I don't have internet connection through these labs. So there's another switch I can use, which is the -N, which is to disable this name resolution. And if I click on it, I can see the set of packets inside it. I can limit the number of packets within it by using the -C account. So when I do -C account and then I'll say only give me 15 packets. Okay, so this will allow me to actually just view 15. Where is the start of this? From here. Okay, so let me enlarge it with this. Okay, so only 15 packets of this. And as you see in this, you have some communication between this client and this server. You know that this is an FTP server because this is the port number. And you see that the FTP service is actually requesting access or credentials to access this, and then that the login is failing. So what's happening is that client is trying to is failing authentication every time, which is an indicator that potentially could be a brute force attack. So the remaining part of the PCAPs is basically just repetitive kind of failed authentication between that client. So if I go back one step to my workspace and I show you, I do an LS as well here, we can see also that I have a custom-based Zeek script here. Okay, that's called Zeek brute force detection. So I'm going to be using this brute force detection basically to do to enable this on this PCAP file that I just showed you to detect this brute force attempt, right? But before I do this, let me show you a bit what is the content of this, just to understand a bit the context, similar to what I showed you in the presentation in terms of the scan, but here it's more on the on the brute forcing. Okay, so if I do VI, just a command to display, I can go into this file, and this is by default, it's a Zeek detector. There's plenty of Zeek detectors that you can develop, but also you can download from the community, right? And this is the power of Zeek, is that it's very strongly supported by the community, right? So this is obviously you see obviously the technical details of this, but I just want to show you a few things. So here you have the threshold that I talked to it in the presentation. So it says basically if I have a failed login credentials, whether username and password, within a 15-minute period, then this should be basically a brute force attempt. Obviously, there is also the handling of this. This is more technical information that eventually you will write part of it in the coming lab. So don't worry about it now at this stage. Okay. But the idea is that I have this detector and I will use this detector. And since this is a detector script, if a brute force is actually being detected, because I'm monitoring the failed logins here, okay, it will write to the notice log, right? So the notice log is where I can observe any anomaly that have occurred using this non-permanent filter or the detector that I'm using here. Okay, so to quit from this, just colon and Q, I will be able to quit from this VI command. I'm running just a bit out of time, so I will finish this lab and we'll conclude this lab session. Okay, so what I need to do now is basically I want to actually run this capture file and use the Zeek brute force detection to detect this brute force. Okay, so what I'll do is I'll run just the Zeek command. Okay, I will read my sample that is there, which is part of the sample, and this is the brute force PCAP. And what I will tell Zeek is process this PCAP file but also apply to it this detector basically. Okay, so I gave it the brute force pickup, okay, and I told them to use this specific Zeek detection. So again, these are the default, but Zeek will process this and will generate several files. One of these files, if I see here, I see that there's a notice.log, okay, and this and there's also a connection.log files. So let's investigate them, both of them. So first of all, let me investigate the notice log file. Okay, so the notice log file actually is the log file that has been written because the Zeek has detected that there's some violation on this. So there's a matching between the failed attempts, the variables that have been defined in the Zeek, and what actually happened. So that's why there's there is a FTP brute force attack that have occurred here, and this is why there was a writing here, and it tells you that this client attempted to fail. It exceeded actually this threshold of 20 fail nodes. So this is the minimum threshold. So I quit. I want to just at the end show you the connection log. So the connection log is also one of these logs that is excessively inputted to other daemons, other services to actually process the information. And you can see that there's some communication that have happened here, and this is where obviously you can see it here between the different between the server and the client that actually tried to brute force. And as you see here, it sometimes could be messy, a bit messy, and this is why actually in the second lab you will use certain utilities, Linux-based and Zeek, by Zeek native, to actually process this information to extract exactly what you want. So for example, you can generate time series of this information. You can generate the most targeted destination ports. And this is very relevant in port scanning, for example, and other utilities. Okay. So because I'm running out of time and we have a panel to manage of this, I will conclude my session now. I wanted to cover another lab which is related to the performance, given that which is lab 10. But given that we're running out of time, I will complete. I'll conclude for now. Okay. So the next item is basically a small break. But I want to again thank everyone that have contributed to this workshop. A big thank you to Dr. Jorge and his team, and Dr. Ghani, and all the panelists, including Jason, of course, and all the NDG team for their help. And I hope that you really benefit from these labs, especially the work by Dr. Jorge and the USC guys have been exceptional on these labs. So I really hope that you benefit from these labs. And from my side, from the Pro Labs, we can promise you that we will be developing more labs on this. We will moving to Mininet, and please keep in touch, try the labs, enjoy the labs, and if you have any questions, reach out to anyone of us. Okay. So what we will do is we'll take a very small break. I would say 5-minute break, and then we will be ready for our panelists that we will be asking them a few questions about security relevant questions about science DMZs and high-speed networks, and then we can conclude from there. So let's take